Good morning everyone. Well, today we're going to be looking at sketching gradient functions, which is a little different to some of the other differentiation stuff we've done, and it's quite it's a thing where you've got to get used to sort of visualizing what's happening with the gradient of a curve. So if you have a look at this little table, you'll probably think, what's going on with that? And what that little table was talking about was how we interpret a curve. If we're given a curve, so I'm told that y equals a function of x is just giving us this curve. We're not told what the equation is, but we're asked to sketch what the differential would look like, what the curve would look like that tells the story about what's happening with our gradients here. So the question, I'd like to make a sketch of that, and also the question which is here, sketch the gradient function y equals f dash of x, that's the differential of x, showing the coordinates of any points where the curve cuts or meets the x-axis. Now to do that, I like to split the curve into a few zones of where the different things are happening. Now we've got a stationary point here and a stationary point there. Until that stationary point, I'm going to call zone 1. I'm just going to put a little dotted line down here and call that zone 1. And then between this stationary point and the next stationary point, it's on a way down. It's a negative gradient all the way down there, isn't it? And that I'm going to call zone 2. And then after that, it just gradually gets more and more positive, doesn't it? So I'm going to call that zone 3. That's just going to help me consider each part once at a time. Then I'm going to put a little table together so that I know what I'm going to draw before I just try and sketch it, because otherwise it's very confusing. So my values of x in zone 1 are always smaller than negative 1. So I'm going to say, right, when x is less than 1, this first column here I'm going to call y equals the function of x. So we're talking about this curve. And what is happening here? I've got a positive gradient, haven't I? So that's all I'm thinking about, positive gradient. And that's what we want to be reflected here. Now if you've got a positive gradient, that means that it's going to be above the curve, above the x-axis, anytime, because our gradient is positive. Then the next thing that happens is, that was zone 1, then we get the stationary point. So when x equals negative 1, it's stationary. And what does stationary mean? That means that it's going to be that means it's going to be a value of 0, isn't it? A 0 gradient. And that means cutting the x-axis, because the x-axis is the line y equals 0. Now I've gone from there, I'm now into zone 2, between the two stationary points, and what's happening? The gradient is negative all the way through here. So I'm looking when x is bigger than -1 and smaller than +1, in all that time I've got a negative gradient. So a negative gradient will always be below the x-axis, because our result, our y value, is telling us what the gradient is. It's telling us it's negative, so it must be below the x-axis. After that, we move to our second stationary point, which is x equals 1. And if it's a stationary point, then that means that the gradient is 0. And that means that we are cutting the x-axis again. And now all I've got left to consider is zone 3, and in zone 3 it's going up all the time, so it's a positive gradient. So we're looking at when x is bigger than 1, our zone 3, and that is a positive gradient, and that means that it must be above the x-axis again. Now we've been asked to sketch it, so I'm going to use this to do that. So it's only got to be a sketch, we don't need to worry about anything other than just recording any important points. So where it cuts the x-axis will be one thing. Well, we know it cuts the x-axis at -1 and +1. So if I just go the same distance either side, right, -1 there, +1 there, I know I'm going to be cutting the x-axis there. Then I know that it's going to be above the x-axis over here, above over here, and below here. And if you look at our graph, it's at our steepest, our curve, right in the middle, isn't it? So if it's at its steepest, it's at its most negative, which means it should be the bottom of the curve we get for our differential, what we had before. So that is sketching the gradient function. So this is the curve that tells us what the gradient is there. That's our first example. We've got just one more, then we've got some practice. Here's our next question. You may want to pause the video, copy this one down, and then I'll show you the sketch of what this looks like. So here's our curve, and then we're going to make another little table like we did last time and have a little look at what that does. So we haven't got so many zones to worry about this time. The first zone is coming down here until we get our stationary point. We don't need to worry, by the way, about where it cuts the x-axis on the original curve, because what we're worried about is the gradient, and the gradient is actually still doing the same thing here as it is there. It's negative, but it's gradually getting less. So if I look at my zone 1, which is when x is smaller than -3, it's always negative, isn't it? So what are we putting here? We're putting y as a function of x, so the curve we're talking about, the gradient is negative. So we're thinking we're going down like that. And what that means for our sketch of the function, the gradient function, is that it's going to be below the x-axis because it's negative. Now at this point here, stationary, when it's stationary, that's 0. So if the function of x is 0, that means that our y plot will be the x-axis. So this is going to cut the x-axis when x is -3. So that means that the gradient is 0, which means it's stationary. Moving on after that, we're now going up, aren't we? So if we call this zone 2, it's always positive. So when it's bigger than -3, it's always positive. So it's going up. So that means it's going to be above the x-axis. But what's also happening is it's getting closer and closer and closer to being 0, isn't it? Which means we're going to have an asymptote getting closer and closer and closer to 0. What does that look like? That's going to look like our first important point to show on here is going to be -3 because that's where it's going to cut. So it was negative before then it's going to be positive, and then it's going to come back down again towards 0. So this asymptote that was here, that was at y equals -2, translates to one here which is at y equals 0, or the x-axis. So that is the asymptote, which was the second thing we were asked to do. And we've got that point there shown. If they ask you to give the point, you should put -3, 0. We do not know what height that's going to be there because we haven't been given enough information. Okay, you may need to watch that more than once before you get the idea of what's going on. I'd like you to have a go at all of exercise 12J on page 278. There's just 2 questions, although there are 6 different ones to do on question 1. And let me know how you get on. Okay, great. Bye bye.